All right, guys, let's go over this. Hopefully we'll be able to get our notes in. This is just like normal. All you have to do is read the problem and come up with a system of equations that would help us solve it. This one says your family is planning a 10-day trip to Disney. Your family estimates that it will cost $325 a day to go to Epcot and $490 a day to go to Magic Kingdom. If your family has budgeted a total of $3,910 to spend on this trip, how many days can you spend in each park? Write a system. You have to look for what you've been asked to find. What did this problem ask you to find? Find what? How many what? What does it say? How many days can you spend in each park? That's exactly what you have to do. Find out how many days you can spend in each park. Well, guys, you're only going to how many parks? 2, Epcot and Magic Kingdom. It's always 2. You're only using 2 variables, so it's always 2 things you don't know. So we are going to say, well, what would be a good variable to use for the number of days you can spend in Epcot? E. So E equals the number of days in Epcot. Got it. And I think it's important that you write this down so you can remember who E is representing. That way you use it properly in the equations. All right? Well, the other park you're going to is Magic Kingdom. You got to find out how many days you can spend there. So what would be a good variable to represent the number of days you spend in Magic Kingdom? M. So M will equal the number of days in Magic Kingdom. Perfect. All right, let's write some equations. So they've given you clues. They talked about how long you're going on this trip for, and then they talked about the amount of money you planned on spending. So let's write an equation about how long you're going on this trip for. Guys, you're going to spend so many days of this trip in Epcot, and you're going to spend so many days of this trip in Magic Kingdom. But the trip is only how many days long? 10. So what do E and M, these days, have to add up to? What total number of days? 10. So E, the number of days in Epcot, plus M, the number of days in Magic Kingdom, better add up to your 10-day trip. All right, so notice that equation has nothing to do with the money. The money will be used as our second clue to write our second equation. All right, they said it's going to cost you $325 a day in Epcot. So guys, if this is the number of days you spend in Epcot, it's going to be $325 for each one of those days. So how do I find out how much money you spent in Epcot?
325.
We're adding them together. 325 per each one of those days, so times E. Plus, if that's the number of days you're going to spend in Magic Kingdom, you're going to spend $490 a day there. So how much money did I spend in Magic Kingdom? 490 times M. And then that better add up to how much total money do you have to spend on this trip?
3,900.
Perfect. And you're done. And I saw a lot of you write that down. So that's perfect. And then I'm not going to make you solve it because we're going to do plenty of solving tomorrow. But I hope you understand I'm a big elimination fan. I would either get a negative 325 there and eliminate E, or I would get a negative 490 there and eliminate M and get the ball rolling. All right. Today, it's our last day of the system word problems. And I always save these problems for the last day by themselves. Because at this point, you've pretty much gotten into a little bit of a rhythm. Things are feeling a little bit more comfortable than they were in the beginning. But the problem with today's problems are, these are all about mixtures. And when you're doing a mixture system word problem, they always leave a number that you need out of the problem. There's always going to be one number that you need for one of your equations that will never be written in the problem. And you have to find it every single time. The good news is you find it the same way every single time, but it's never written in the problem. So you have to get used to that, all right?
So more steps.
It's really not more. It's like one teeny tiny little step. I wouldn't even call it a whole step. All right? Come on, Dave. Put it away.
Step.
Yeah.
I had it written down.
I know. All right, so just be careful with these mixture ones, and you'll see what I mean. All right. Yeah.
Boom.
Well,
Everything tomorrow.
Tomorrow? Oh, you don't want to know.
is it a quiz?
No. No, we won't quiz until next week. All right. So like I said, today, it should feel very normal with like a little bit of a curveball thrown in there, but we are doing mixture system word problems. So I gave you some reminders up top. To get these problems started, please establish what two things the problem is asking you to find, define two variables to represent those two things, and then write two equations using those two variables, and then there should be two different clues that you can use to write each one of those two equations, all right? And then I put a warning on today's problems. Mixture problems never give you the last number that you need. Now, hopefully, if you set it up the way I set it up, it's always the last number. But it's never going to be written in the problem. You are going to have to find this on your own every single time by doing this. Thanks, Brendan. I'm not going to tell you yet. Let's figure out how you get that missing number in the first example, and then we'll fill it in because it's what you're going to do every single time. So everybody look at example 1. Let's do some mixtures. And they're not the most glamorous because a lot of times you're mixing food, and we're going to be mixing a lot of nuts and then meat in the one problem. So it's kind of gross. But I think there's a problem in the homework where you get to mix candy. All right. All right. Here we go. Example 1. A grocery store. Oh, I don't want to move it up that far. A grocery store has almonds that sell for $5 a pound and peanuts that sell for $2 a pound. How many pounds of each must Joe, the grocer, mix to get 150 pounds of a mixture that sells for $3 a pound? All right. At the end of the day, guys, what have you just been asked to find? Where's the question?
Mix to get 150 pounds of a mixture that sells for $3 a pound.
No, where's
How
the
many pounds?
How many pounds of each must he mix? Well, guys, what two things is he mixing? Almonds and peanuts. So your job is to find out how many pounds of almonds and how many pounds of peanuts he has to put into this mixture. So what would be a good variable to represent the pounds of almonds that he has to put into this mixture? A. So let's let A equal the pounds of almonds that he will put into this mixture. All right, what else is he putting into this mixture? Peanuts. What would be a good variable to use for the pounds of peanuts that go in? P. So we're going to let P equal the pounds of peanuts. Okay. Well, guys, first of all, let's just think about this end mixture. The end mixture has to be how big? Nope. 150 pounds big, and he's got to be able to sell it for $3 a pound. All right, think about it. Well, guys, he's trying to make a 150-pound mixture by mixing almonds and peanuts together. If this is how many pounds of almonds he's going to use, and this is how many pounds of peanuts he's going to use, they better add up to how many total pounds? 150. So that's our first equation. A, the pounds of almonds, plus P, the pounds of peanuts, better add up to the end mixture, which is 150 pounds big. So A plus P equals 150, right? So normally there's always an equation that's got nothing to do with the money. That has nothing to do with the money. It's all about the size. How many pounds of each equaling how many pounds of mixture in the end. All right, now in your second equation, now let's bring all the money in, all right? He's going to use this many pounds of almonds. What does 1 pound of almonds sell for? $5. So guys, if this is how many pounds of almonds he's using, that's $5 for every single one of those pounds. So how much money is he using for almonds? If it's 5 per A, that's 5 times A, 5A. Plus, if that's how many pounds of peanuts he's going to use, what's 1 pound of peanuts worth? $2. That's $2 for every single one of those pounds. So that's going to be 2 times P. And then it equals blank space. Everybody put a blank space. This is the number that will never be written down in the problem. Now, put your pencil down. You don't write this down. What is the only number written, Jake, I swear to God, I'm going to take it. What is the only number that you have not used yet? Everybody wants to put 3. Right? Oh, look, it's the last number. It's got to be 3. Put your pencil down. Do not write this. If it was 3, guys, think about why it couldn't possibly be 3. A is the pounds of almonds that you're going to use, right? Let's say you used 1 pound of almonds. What's 1 times $5? That's $5 in almonds just by using 1 pound of them. This is the pound of peanuts that you're going to use. Let's say it's 1 pound. What's 1 pound times $2? Guys, if you only use 1 pound from each, right? And we're making 150 pounds, so we're using a lot more than 1 pound each. But if you only use 1 pound each, how much money does your mixture already cost? $7. So how could it possibly equal 3? You're already in it for $7 just by using 1 pound of each. So it couldn't possibly be the 3.
Wouldn't it equal C then?
What's that?
Would it equal C, like as like a
Oh,
variable?
no, we need numbers here. We don't want a third variable in a 2-equation system.
Oh.
The number is here, we just have to find it. So guys, think about it. This is how much money the end mixture is worth. We're going to use $5 per pound of almonds plus $2 per pound of peanuts, and that's going to equal some total amount of money. So you have to figure out how much money is the end mixture worth. Well, guys, how big is the end mixture? 150 pounds, and what's every single one of those pounds going to sell for in the end? So that's $3 per 150 pounds. So that's $3 for the first pound, $3 for the second pound, $3 for the third pound, $3 all the way up to the 150th pound. So if there's 150 pounds of mixture and they're worth $3 a pound, what's the total amount of money that mixture is going to be worth? What do you do?
I don't
No. Multiply. $3 times 150. What's $3 times 150? EV3. I do. Oh, really? I just started notes for today. It's word problems that I would hate for her to miss. All right, thanks. Bye. I will never understand that. Should be a written rule. You can't get called out of math class. All right, so whoever it was, you're not going. No. All right, here we go. So all you have to do to get that missing number is multiply your end mixture information together. It's $3 a pound. There's 150 pounds of it. That's going to equal 3 times 150. How much money is that? $4.50. So that's how you find the missing number. Whatever they tell you about the end mixture, multiply those two numbers together every single time. All right, so we will find it on our own by multiplying the end mixture information together. So whatever they tell you about the end, normally it's like a size and a price, or a size and a specific quantity, but that's what you are doing. To get that missing number, whatever they tell you about the end mixture, multiply those two numbers together. All right, let's go down to example 2. I had all the other classes solve this because it's a pretty easy one to solve, because I want to kind of get you in the mode of solving again, but if this fire drill is going to happen, I want to go on. If you solve it, you should find out that there needed to be 50 pounds of almonds and 100 pounds of peanuts, if you have any interest in trying it on your own later, okay? All right, let's try it again.
How can you tell the difference?
Say it again.
How can you tell the difference
Of what?
of like the different powers? Like these ones are.
These ones are going to say mix in it. If they say mixture, you know it's a mixture problem. They will say something about mixing. Otherwise, it's just a normal problem. All right, let's try almost the exact same problem again. This time we got ShopRite. He's got cashews that sell for $10 a pound and walnuts that sell for $15 a pound. How many pounds of each must Tom, the grocer, mix together to get a mixture that is 100 pounds big and he can sell it for $14 a pound? All right, guys, what have you just been asked to find?
How many pounds?
How many pounds of each must he mix? What's he mixing?
Walnuts and
Everybody, come on.
And
And cashews. So what's the variable we could use for cashews? C. So that's going to be, again, the pounds of cashews. They asked us to find how many pounds. So that's going to be pounds of cashews that we need to put into this mixture. And then we're mixing it with walnuts. So let's do W. That'll be the pounds of walnuts. So we're going to take so many pounds of cashews, and we're going to mix them with so many pounds of walnuts to create a mixture in the end that is how big? 100 pounds big, and it's gonna sell for $14 a pound. All right, well, guys, if this is the pounds of cashews he's going to use, and this is the pounds of walnuts he's going to use, they have to make a mixture that is how many pounds big? 100. So what do C and W have to add up to? 100. So C, the pounds of cashews, plus W, the pounds of walnuts, butter that up to the 100-pound mixture that you're making, right? It's got nothing to do with money. All right, now second equation, now let's bring the money in. What does 1 pound of cashews sell for?
10.
That's $10 per C. So that's going to be 10 times
C.
Plus, what's a pound of walnuts sell for? 15. That's going to be 15 per W, which is 15 times W, and that equals blank space. That is the number that they never give you. And what's the only number you haven't used? So everybody wants to put 14, but guys, we're already in this for $25. You use 1 pound of each, you're already in it for $25. So in the end mixture is how big? 100 pounds, and it's going to sell for how many dollars a pound? 14. So if there's 100 pounds, and each one of them is worth $14, how much is the end mixture worth? 1,400. 14 times 100. Multiply that end mixture information together, and you get 1,400. I always like to write that so you can always see where the number is coming from. But if you just write 1,400, you're right. I always like to put it so you can look back. All right? All right. And then you would solve. I want you guys to read and do number 3. Pick your variables, set up your 2 equations. Let's do this. And then I even want you to solve it. Let's solve one. Because tomorrow is going to feel like solving on steroids. So let's just at least get a little bit of solving under our wing again. Oh, it's all jacked up. No, they're not. They're not good for you. Wait till you see what they do to math.
One day we started.
What? One day.
One day.
Don't do it. They know the drug. Whoops. Yes.
The drug?
Sure, isn't it? We used to have to watch a video on it in health class, and it was the Ben Affleck. You ever see the Ben Affleck steroid movie? They still show that now?
They're illegal.
It's
They are illegal.
they are for a good reason.
Why do it on my own? I have like a seizure.
Come on, Jake's already done.
Is that right?
Close. Where are we? How'd you get that number?
I don't know.
There you go.
So that's like 50 here.
Perfect. What's up? So B and P represent what?
Wait, solid.
The price of them or the pounds of them? So what should they add up to? How many pounds? B and P, if they represent pounds, should add to how many pounds? 10. Now, next equation, bring all the money in. What's each one sell per pound? How much total money are we talking about? Beautiful. Yes, keep going, Shia. Good. Come on, Steven. It is perfect. That's good. Yep, you're good. Perfect.
All right, set it up.
Perfect. So now I'm always an elimination person. So I'm either going to get, now just be careful. Pork is $4.75 a pound. That should be $4.75. I think you just,
I was looking at
I
that
know,
before.
I understand. Yep. And now I would get elimination. I would get a negative number in front of one of the other variables, so I can add them together and eliminate. Perfect. Get it, Steven, let's go. You got it? Do you have that one?
I'm sorry.
Third one? We're doing that one.
Is this good?
Perfect. All right, hold on. What do B and P represent? Well, what about the price of them, the pounds of them? What does it represent? Right, so why would the pounds add up to money? Pounds should add up to pounds. So B and P should add to 10, which is why it's important to recognize who your variables represent. And now, go ahead. Say again. So now 350B plus 475P, this is all about the money. So what's the mixture worth in the end? How much money do we get?
4 and 10 ain't 100.
Wait, what?
What's 4 times 10? Right, you have 4 times 10.
Perfect. Yep. Guys, I'm seeing lots of good systems. Your setup is perfect. All right. When you go to solve them, right, you have to have either the same number but opposite sign in front or substitution. I always do elimination. So I would times the entire top equation by negative 350 to get my b's to cancel, or I would times my top equation by negative 4.75 to get my p's to cancel. You can't add them together because none of your variables go away. You know what I mean? So walk up here. All right, guys, I'm seeing everybody write the equation properly, which is amazing. So let me catch up to you guys. Right, so we got pounds of beef plus pounds of pork that have to add up to 10 pounds in the end. Then you bring the money in, $3.50 per pound of beef plus $4.75 per pound of pork equals, this is the number they never gave you. In the end, the mixture is 10 pounds bake and it sells for $4 a pound. So that's total of $40. 4 times 10. All right, now, so when you solve, I'm a big elimination person. So I'm going to get rid of my b's by getting a negative 350 there. So I'm going to times the entire top equation by negative 350. So that'll be negative 350b times p is negative 350p equals negative 3.5 times 10 is negative 35. Then I'm going to bring this one down. I don't even have to change him. And then I can add them together to make one new equation. When I do that, they will eliminate, which was my goal. Negative 350p plus that is 125p, and then it equals positive 5. And then I'll solve for p by dividing. And then I find out that p is equal to 4. For what? That's 4 pounds of pork that need to go into this mixture. And then if p is 4, 4 plus what gets you 10? 6 pounds of beef. Say it again. Did you get 6 and 4? Then you're not right. Oh, did you get rid of your decimals?
Yeah.
So you would do 350b, 475, and then that would become 2 decimals would be, hold on, this was 40, not 400 to start.
Okay.
Because if you're going to do that, you're going to move him 2 spaces, him 2 spaces. When you move 40 2 spaces, it makes 4,000. All right? All right, perfect. Guys, I saw a lot of good systems there. Good job. All right, now I'm going to throw one more monkey wrench in. If you're not mixing, like food, a lot of times what they have you mixing in these problems is like chemicals. So it's not going to be about money anymore in the second equation. It's going to be about percentages in the second equation. Which, guys, you're going to treat it just like money. It's like when you bring them in, you're just going to be multiplying with the variable. But you have to understand, when you use a percentage in a problem, you need to know its numerical value. So, for example, if you have 50%, right? Guys, that's 50 out of how many total percent? 100. So that's 50 out of 100. That's 5 over 10. That's 1/2, which is 0.5 or 0.50. So when you take 50% and convert him to a number, because 50% isn't the number 50, it's a percent. 50% as a number is 0.50. So I need you to know that when you use percent in a problem, you have to convert it to its numerical decimal equivalence. So guys, if I said 25%, really what number is that? 0.25. If I said you had 40%, what number is that? 0.40. If I said 8%, what number is that? Oh, 0.08. Excellent. All right, so please know that. If you want to use a percent, we're going to have to convert them to decimals, okay? All right, let's do it. Let's look at that example. Let's look at 4. All right. It's going to sound 10 times harder, but guys, it's really not. This one says a chemist has one solution that has 50% alcohol content, and he has another solution that has 10% alcohol content. If the chemist needs to obtain an 8-ounce solution that is 20% alcohol content, how many ounces from each solution should he mix? Okay, I know it's a lot. What have you just been asked to find? How many ounces from each solution? Exactly. Well, guys, he's mixing 2 solutions. One of them has what percent alcohol content? And the other one has 10%. So think about that. He's taking one solution that has 50% alcohol content. He's mixing it with another one that has 10% alcohol content to make one solution that is 8 ounces big and is 20% alcohol content. Okay, so now this is where a lot of students just start to use X and Y, but I'm not that simple. So if I said, how many ounces of the 50% alcohol content do I need? What would be a good variable to represent that? A lot of students just say X. I say F for 50. That's how my brain works, but you do whatever you got to do. So I'm going to let F equal the ounces of 50% alcohol content that I need from that solution. All right, we're mixing it with another solution that is what percent alcohol content? 10%. What might be a good variable you could use for the 10% alcohol content? I use T for 10, but you use whatever you got to do. So that'll be the ounces of 10% alcohol content solution that I'll use. Is everybody okay? So we're taking the 50% one, we're mixing it with the 10% one to make one mixture that is 8 ounces big and it's 20% alcohol content. All right, so if I'm going to use so many of these ounces, and I'm going to mix them with so many of these ounces to make a mixture that is how many ounces big? 8. So what do they have to add up to? How many ounces? 8. So F and T have to add up to the 8 ounces that your mixture is going to be. So it's got nothing to do with the percent yet. We're just talking about how many ounces we're using. So F, the 50% solution, plus T, the ounces that I use with the 10%, better add up to the 8-ounce solution that I'm trying to make. All right, now, just like before, the second equation is where we would bring the money in, right? Now we're not going to bring money in, we're going to bring the percents in. So think about this. If I use this many of the 50% alcohol content, if I use this many ounces, out of all of those ounces, 50% of them are already the alcohol content. So how do I find 50% of those F ounces? What's 50% times F? What's 50% as a number?
0.5.
No.
Or-
Zero. I just say 0.50. Is that 50%?
Oh, yeah.
So 50% of those F ounces, if 50% times F, that's 0.50 F. Plus, if this is how many ounces I'm going to use of the 10% one, guys, 10% of those T ounces are already the alcohol content. So what's 10% of T? 0.10 times T. So just like you would bring the money in, you're just bringing the percents in. And then it has to equal blank space. They do not give you this number. In the end, your mixture has to be how big and what percent alcohol. So what is 20% of those 8 ounces? How many of them will be the alcohol? Well, how do you find 20% times 8? How do we always find the last number? What do we do? Multiplication. 0.20 times 8. Multiply your end mixture information together. And what is 0.20 times 8? 1.6. So you're just bringing in the percents as if they were money. You're still multiplying them with your variables. And then you're equaling it to that last number that you need to get by multiplying your end mixture information together. And then again, decimals don't bother me. I would either get a negative 0.50 here or a negative 0.10 there and use elimination. All right, let's try it one more time before this fire drill happens. All right, last one. Suppose a car with a 15-gallon gas tank can run on a fuel that is 40% ethanol. I don't know how to say that word. Is it ethanol? Thank you. All day. I need to know how to say that word, Steven. If you can buy fuel that is either 30% ethanol or 80% ethanol, how many gallons of each fuel should you mix to create the correct fuel percentage that will fill this car's gas tank? What have you just been asked to find?
How many gallons?
How many gallons of each fuel should you mix? Well, guys, how many fuels are you mixing? 2. Always 2. One of them is what percent ethanol? And the other one is, you're going to mix them together to fill this tank that is 15 gallons big, and you want 40% of it to be ethanol. That's in the end. All right, so what would be a good variable to use for the gallons of 30% ethanol? I used T for 30, but use X, Y, whatever you got to do. Okay. What would be a good variable to use to represent the gallons of 80% ethanol that you have to use? I use E for 80, but you can use whatever you want.
The following are the afternoon announcements. Bus 143 is bus 190. That's 143 is bus 190 today.
Okay.
Online personal finance.
You are trying to fill a gas tank that is 15 gallons big, and 14% of those gallons are going to be ethanol. So guys, if this is how many gallons you use from one mixture, and this is how many you use from the other, those gallons have to add up to how many total gallons in this tank.
Not completed the course will not be eligible to
15.
graduate.
So T
Have a great afternoon.
plus E has to equal the 15-gallon tank. I use so many of these gallons and so many of them, give me 15. Now let's bring the percents in. If this is how many gallons I use of the 30%, guys, 30% of those T gallons are already ethanol. So what's 30% of T? 0.30 times T plus. If I'm going to use that many gallons of ethanol, of the 80% one, guys, 80% of those E gallons are already ethanol. So what's 80% of E? 0.80 times E equals blank space. In the end, how big is this gas tank? 15 gallons, and what percent of those 15 gallons has to be ethanol in the end? So I have to find out what's 40% of 15. What do? Multiply them together. 0.40 times 15 is what number? 6. And you're done. So I know the percentages feel weird, but it's just like money, guys. You're bringing them in and you're timing them with your variable. Are you guys okay?
Yeah.
All right, you have a homework tonight on quizzes. I am 99% sure that it is 10 questions, but they're all multiple choice. Pick the correct system. I believe the first 3 are mixtures, but the last 7, the last 7 are just normal system problems. They're not mixtures, okay? All right.
Did you put the grades in yet or no?
No.
Okay.